book is going to be heat energy.
Okay.
And when we translate it, it's energía térmica. Okay.
Are you gonna
So
put
thermal
like
energy.
by?
Well, I was
Oh.
thinking about having them put their name, and then on the inside they can put the date.
Oh, okay.
That
'Cause
way
we're gonna
since-
work on it today and tomorrow.
Yes, since we're working on it for 2 days, they can put the date on the page that they work on today, or if they do 2 pages, and then tomorrow they'll put in their 2 pages.
Okay. So
The
how
date.
many pictures, like cutouts of the magazines, like do you want on the? What do you think?
I'm thinking as many as they can put on there. I mean, if they find more than 1 or 2 today, and because some work faster than others, I think it should be up to the student's potential.
So they can make like a collage, pretty much. Then?
Yes.
Yeah, I was thinking of
Yes.
doing 3 today and 3 tomorrow.
That too.
And also, like, if they don't find enough stuff in the magazines, like, they could draw maybe 1.
They sure could, because most of them already know that the sun is something that provides heat energy, and so they can all draw the sun. So I
They
agree.
could, like, they could draw, like, 2
Mhm.
if they can't find.
Okay.
So
6 things.
do we want them to do at least 3 then? And then if they can't find 3, then they can draw the
'Cause
additional.
I know in art they have been working with the cutting skills, but some of them are not really good at cutting yet, so they're gonna take longer to do the cutout. So maybe it's good just put the 3, like for the ones that are really good with them, and if the ones that are, they need more help, they can maybe have 1 or 2, so that way they have more time tomorrow as well.
And then they can do 1 tomorrow?
What do you mean?
Like for the DOL, how many do they have to do in order to pass the DOL?
No, have you been doing it? We made this, I'm making it right now. So just like a word problem, like identify the object that produces heat, and I have I'm gonna put the candle in A, and then right here I'm gonna put like a familiar object, maybe like a pencil or something.
Oh, okay.
And then at the end of the day, you give them the response card.
And they do
And
either
then
A or
we-
B. Oh,
which
okay.
one?
Yeah, because that'll be,
produces
like,
heat.
more like a little project.
Okay. Oh, this is the activity,
Yeah,
and then that's the DOL.
what we
Okay.
did. So I'm
Perfect.
gonna email you guys.
Okay,
The
thank
deal
you.
over just.
This time you use the ruler to make it change direction or to go faster.
I have thousands of rulers, so I can do
All right.
that.
Then teacher will roll the ball again, but this time use a classroom object to help change its location. Maybe a pencil
Yeah, maybe
or one
a-
of the match we have for math and all that. All right, and then the DOL. How can a push or pull change the way an object moves?
Then they should be able
So
to.
when you're rolling, then you can just with the ruler you can just tap it. All right.
Or lay it flat and see how it move when it hit the ruler, like how it slide or change the direction. If they put all their rulers together and they just let the ball move, they can do that too. If they work in a group.
All right, so then Thursday, scholars will conduct an investigation on how force can change the location of object. Because remember, we're focusing on that.
On the force. Like that test, they talk about the ball kicking it really
Now
hard.
that one is where we do flip chart 23B, and is where we put different objects. We have many things in the room we could use. All right.
Do we put those on the table? So
Yeah, you just put them on the table, right? And then what you're gonna do, you provide the scholars with various objects. Scholars will put objects on their desk, and they will move the object closer to, nearer to, and farther from another object. So that's the vocabulary for the day, which I listed down at the bottom.
That's what they need
and so
to
they're
know.
gonna describe. Okay, I moved this one. Is that nearer or closer? Or you could guide them. You could demonstrate where you just start off with something on the focus machine and say, okay, I got these 2 objects now.
Did you put the Elmo video?
What?
The Elmo video
No, I didn't.
about the close and far and near and
we can go to
That was the one.
Where's the video
YouTube
from?
and they do that.
yeah, near and far and
But
then
what
goes
videos are-
Elmo's, go Elmo. I remember seeing him. I watching Elmo.
Is it Elmo?
Yes.
I had a the
It's
one I
Elmo.
found. It was like a cohete. It was like a rocket, but now
and it says now near
Now
far.
make sure
He
that.
goes,
yes, I did see that video before.
Yeah.
I did show my.
And they like that.
So
they like
remember-
that video.
Yes.
Near. There he goes.
So remember, this part is where we're trying to do the process of communication. So we're
Okay.
getting them to communicate their observations. All right.
Okay.
So they're
Very good.
communicating. So they're going to be turning and talking and doing a lot of talking, describing using the vocabulary for the day, the movement of the objects and the location of the objects within each other. Table one is it closer to table 3, or near to table 3, or near to table 2?
Something like that.
Or within their tables, talk to them and say, hey, are you near to him or farther from? All right, now, I know we have some level readers with the English. I'm going to see if Mr. Fernandez can hook us up.
Okay.
Because there's some level readers that can go with this. I put them in there, and then they're based on their levels and what we could have. A couple that the kids could read when they have a chance. All right, now.
Yes.
For
I
I want to do this one. Okay, scholars will plan and conduct a simple investigation that shows how force, motion, and energy are related or a part of everyday life, such as way objects move. The project we're going to do is, so the DO is going to come after the
Is this
the project, yeah, the catapult,
plane?
the marshmallow catapult.
Oh yeah, that's
All right. So
with the rubber band,
what?
with the rubber band. A marshmallow
All right.
and a rubber band.
well.
Now,
They learned
this is,
about air and the balloons.
So before you start, we're going to go back and review real quick.
I thought you were going back to the.
Oh, I'm sorry.
You're doing the science.
Yes.
All right. So what we're going to do is first review the design process real
Yes.
quickly, right? And then you're going to move on to the. Sorry.
Oh, they're engineers.
See, it says students plan and design a marshmallow catapult and build to investigate how the location of an object. Well, it's applied. The objective of each shot is to get the marshmallow closer to a target. All right. So they're gonna have
How
to
much
play
force?
around. Did I put too much force? Or I got to put less force?
They're gonna have to figure that out. They're gonna have to play around with their.
Once built, the students can measure the distance or marshmallow travel using non-standard units. If we decide to do them, they could give them freedom to do it on the floor or whatever, they could measure it with their feet. And that goes along with non-standards what we do in math.
Distance, it took the magnet to like push it or pull it from the string. You see what I'm saying? You can use different strengths of the you use the different sizes of the magnets to have, different strengths.
So you're measuring
It's-
how
I think that was
quickly
in the fusion book. Where's
So
the
you're
fusion book?
measuring like how quick or
Let me see
how
the book.
close it is
I'll show
with
you.
the magnetic field or something?
Let me show you.
I'll look online.
Yeah. So yeah, because it only had a few of it. Even though maybe they're just building on it, maybe nothing new. We see it's nothing new, but we can make what we have better, right?
Yeah.
And we're gonna need these
well,
kids
that's
to
what
do it
was
even
happening
better.
with
Then.
everything, with cars, airplanes. It's been happening, and there's people working on that. There's a friend of mine from high school. She's all over the web. She works for GM in Michigan, and she invents race cars. That's what she does.
Look,
And if
there's
you
a
see
little-
her, you're like, really? She was like the quietest girl in school, super shy, blah, blah, blah. She just went into engineering and she got a job with GM right after college. And she's been there, and that's what she does. She wears a race car shirt. I'm like, I don't believe this, because I know her. Cars have nothing to do with her personality. She just,
But it's the engineering.
Yeah. There's a
But,
thing here
well,
that
but
talks about magnets.
whatever she did,
talk
that was
about
the job that she
what it
found.
It
Because you can.
says magnets are used in hospitals to take pictures of patients. Special trains that move very fast are moved by magnets.
Well, you know what? It's done by a magnet. The MRIs. Is it the MRIs? Right. The MRI
So
is a huge
everyday
magnet,
life,
because
we
I've
talk
done a
about the
couple.
trains, we
Is
talk
a
about
big magnet.
in our medical, even in our medical fields, MRI taking pictures of our whole inside,
magnets.
how they use them in the trains, everyday life, and you may not even see them, but they're there. So magnets is a great unit. I mean, and we can introduce stuff in their everyday lives that they probably ain't even thought about.
No.
I'm gonna try and find a video.
Oh, of course not. They're
But it felt warm to this table, even though it felt cold to this table, and they're
Right.
able to say, well, the heat went
Oh,
from their
that
hands.
perfectly.
So
Yeah.
it ended up being a good,
Yeah.
real world learning situation, but it was
Very
not
nice.
at all what we planned.
That happens. It worked out well. We're doing pulleys on Tuesday.
Do you still have pulleys from last year?
The pulleys that we created from last.
We had some. I bought some, and
Yes.
I shared them with the team last year. I know Miss Soto gave me hers back.
Did I not give you yours back?
I'm not sure. I don't remember.
I can check. My
I haven't
science
checked how
box.
many I
okay,
have.
let me check my science box.
I'm pretty sure I did.
Okay.
I don't think I would keep those, but let me double check.
I know we moved wedges to Friday, so we're gonna have a lab on wedges and the position changes.
Right.
I'm trying to ignore this camera, but the truth is I feel self-conscious. I'm trying to act natural, but it does make me feel self-conscious. So, do we want to do that in the lab and like push all the tables out and have space in the middle? Or do we want to do that outside?
I would love to do it outside.
Because then we have
Because
more,
that's where, more room we
And
can
they
do
can even
things,
kick
and they
it.
can kick it, and they can do,
throw
and it's
it.
more like this is how we use the ball. We're usually outside. We're not inside
Right.
of a building, so it gives them more of a connection that way. So I would like to be outside.
Yeah. Can we do that, Mr. McKenzie? Can we do
Did
that?
you have one already, Hector? Are you did it ready? Okay, ready? And pull it towards you. Pull. Very good. So a pull is a movement, a motion that is towards you. Are we ready to go outside?
Yes. Yes.
All right. I need my friends that have a
would be hands-on. Okay, so that for the intro, they're gonna do page 30 and page 225, and that's what they're gonna do in the classroom. This is gonna be the intro.
We learned from this. Okay, all right.
And
we're
then-
gonna have flip charts on the desk.
Yeah, and I think I have enough for you. I know I have 4, so I can let you borrow some too. And then once we do that, we are gonna go to review the vocabulary, which was insulator and conductor, because they got to do that with the, what is that called? The craft stick. So they're gonna review that vocab, and then they finish this. And then they go to page 230 and 231, which is where they finally analyze what is going on with these circuits. So with this circuit. So I think that's a good day.
Okay.
The only thing I'm having trouble.
Do you ever watch those videos online with the book?
I haven't. Have you?
I was just wondering what you thought about those.
I've never watched them. Have you? You've seen them? I don't know.
Yeah,
I
I let the kids watch them and.
How do you get into
Yeah,
that?
tell us about it, Miss Hughes.
No, seriously, I don't know how to get into that. I don't know.
You go to Think Central.
Mm-hmm.
I'm clicking on it right now. Hold on. I'm sure when you put in your username and password.
Your DISD username and password?
Well, your username and then your password is D, capital D with an exclamation mark.
Okay.
SD and then your birth year.
Oh, that's right.
So.
She went to eat lunch.
Welcome to the lesson.
Are those y'all's?
What is an electric circuit? In this lesson, you are going to investigate how electric charges pass through various materials.
So then I'll hit the next button and then
Flick the switch between the 3 positions and observe what happens.
So and then you can go with the class and a minute.
Can you explain your observations? What is the purpose of the battery? As you go through this lesson, try to answer these questions.
Did you know that your house probably has dozens of electric circuits? Electricity flows through circuits in computers, televisions, appliances, radios.
So we'll have to
and
go
lights.
through the lesson, online lesson, if you would like to use it, and see which ones would be good to show the class as part of like the, I guess the engagement piece.
An electric
to
circuit
get
is
them
a path
focused.
through which electric charges.
Thank you for joining our Science Department Planning. 5th grade will plan next. And you will also see how we implement the plan within our classrooms. Thank you for joining us.